This is TechSNAP, episode 430, recorded on May 17th, 2020. Hello and welcome to TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and once again, I'm joined by Jim.
How you doing, everybody?
It's wonderful to be joined by you, Jim, one last time. And we've got a great final episode for the both of us.
Yeah, Wes, looking forward to talking about both Fedora and everybody's favorite, ZFS.
Oh boy, those are both favorites of mine. Let's start things off with Fedora, though. You know, it is release season for both Ubuntu and Fedora, and unfortunately, I think Ubuntu 2004 has gotten a bit more coverage. Of course, we've talked about both over on Linux Unplugged, and honestly, I've been having a great time with Fedora 32, and I think it's a great release. So I was pleased to hear that you've been doing some testing yourself.
I have, Wes. This is, honestly, it's the first time I've spent any significant amount of time with Fedora. Like a lot of people who aren't inveterate distro hoppers, I kind of found what worked for me pretty early on and, didn't really feel a whole lot of need to deviate from that.
Ouch, but your point is well taken.
I've been a big fan of the Debian ecosystem for a very long time. I used Debian before Ubuntu was a thing. Discovering Ubuntu on the desktop, that's actually what brought me into desktop Linux as opposed to just on the server to begin with. And although I didn't play with it myself, what I heard about Fedora is, it was where you went for the absolute most bleeding edge stuff, and it was fresh and it was great, but things might be broken, more often than in some distros. And that just turned me off completely because I fix broken things, all day long professionally every day. And the less I have to fix personally of broken stuff, the happier I am.
Right. No sysadmin wants to go home to another level of admin problems.
Well, some actually do. I'm just not one of them. But I've been really interested to look at Fedora in particular because, for several years now, they have defaulted to the Wayland display server. And I have been hearing for so long about how Wayland is, the amazing next generation, much higher performance, does things much more sanely, yada, 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 but I'd never experienced it in person. And that also meant that I felt that to really give Fedora a chance, I couldn't just do my usual routine of only spinning it up in a VM. I really needed to have it running on the bare metal. So that's exactly what I did on a Hewlett-Packard Dragonfly Elite Generation 1 laptop, i7, really nice little machine. And I did end up eventually spinning up a Fedora virtual machine as well, largely just because it's a whole lot prettier taking screenshots in a VM than, constantly taking pictures of a machine that you're working with on the bare metal.
That's how you can tell you're a real pro, Jim. Well, let's start things off at the very beginning with the installation. Now, I really do like Fedora, but Anaconda, the installation GUI, well, unfortunately, it's never really been my favorite.
Really? That was actually one of the things that I kind of liked. Now, I will say that, like a lot of my experience with Fedora, I found it a little slower than I was used to. It felt kind of sluggish, both booting up and getting through the install sequence overall. But the GUI was very bright and attractive, and I didn't have any issues getting through it. I particularly liked the Blivit GUI for, if you want to do your own advanced partitioning and disk layout. Seemed very complete and very approachable. I liked it a lot.
That's a great point, Jim. Honestly, one of my bigger complaints with Anaconda over the years, a lot of that was the disk partitioning system before the Blivit option. So now that they've added that, well, honestly, it's not so bad. And it does work nicely. Once you click through a few times, you're at the end. I do find it occasionally confusing the way that you have to go select the disk layout option, even if you just want to let it take over the whole drive, and then not change anything and hit done. So that part is still there. But other than that, it's fine.
Yeah, that really bugged me too. The thing that really got me about is, Fedora presents it to you as an error. And it's not that obvious that it's clickable. It doesn't really look like a button or, there's no bevel around that area. So you're just kind of staring at it a little confused at why is the automatic partitioner selected, but it's an error until finally you just give up and click on it to see what happens. And of course, that then gets you into the partitioner.
Yeah, that's definitely true. I do like how snappy the rest of it feels. It just sort of writes out the installation disk, reboot, and then you go set up your account and log in after you've installed everything.
I mean, it's not really a problem, but it surprised me. It felt a little weird and uncomfortable not to be prompted to set up a username during the actual installer, but, on your first boot into the actual system. So I'm like, do we just kind of have something running as root on first boot on the system? I mean, I don't really have an objection to it, but it definitely felt strange. It's not the order I'm used to things getting done.
Yeah, it's definitely a different approach, although I do like getting through the installation phase as quick as possible and just booting up into my real environment.
The other thing that bugged me was it never prompted me to set a host name. Matter of fact, I think the shell says just that you're logged in at localhost. I did not dig that. You should please ask me what I want to name this machine during the installation process, in my opinion.
I agree. It's nice to have a name for a machine, especially when you have multiple of them on your domain, right? I mean, if I'm going to be using this thing and it's going to show up in logs and other systems, it needs to have a meaningful name.
Yeah, at least when that happens on FreeBSD, it calls it amnesiac, so you know something's wrong.
I do love that. All right, well, once you got through the installation phase and rebooted into your desktop, what did you notice?
Much like with Intel Clear Linux, it's a very upstream GNOME. There hasn't been a whole lot of customization. I don't love their defaults. I don't like the launcher being completely hidden unless you either click activities or, hit the meta key. That's a big one for me. I absolutely can't stand that. That bothered me so badly that until I had gone through a little journey figuring out that I needed the dash to dock extension and figuring out how to get that installed and going and finding the settings once I had the launcher always exposed to keep it from auto-hiding itself, it wasn't until all of that that I also noticed that my minimize and maximize buttons had gone from the window dressing, and I very much do not like that either. And I'm sure there is another, GNOME extension or tweak to bring those back, but I never did find that, and it bugged me intensely.
That does definitely stand out, and to my mind is one of the trickier aspects of reviewing a distro like Fedora. By and large, they mostly just integrate a whole bunch of upstream software that they didn't write, so you're stuck, for better or for worse, with whatever the upstream defaults are. And in the case of GNOME, maybe not to everyone's taste.
Maybe not. You remember that outrage when GNOME 3 first launched, how much absolutely everybody on the planet hated it?
Yeah, absolutely. I think those were also way back close to the Unity days.
Yeah, they were.
On the flip side, I do really appreciate that about Fedora. It's a place to get to play with all the latest and greatest open source software out there. Many times when there's a new feature, whether that's a new system D release or something experimental in the Linux kernel, Fedora is the first place that you're going to find it. Now, that doesn't always make it the best stable workstation, but it does put you right on the bleeding edge and is a fantastic place to get some fun in.
Yeah, it was certainly an easy way to get to play on the 5.6 kernel without needing to touch anything. Just install Fedora 32 and DNF update and restart, and bam, you're on 5.6.12.
Another feature that stood out to us over at Linux Unplugged was the enablement of early OOM, a user space out-of-memory daemon that tries to avoid ever having the kernel kill a process that's eating all your memory.
I just avoid that by provisioning my systems properly, but I can see how that would appeal to a lot of people.
Yeah, and it just made me think it was one aspect of Fedora thinking about holistically the experience. I think as they've changed their model over the years and adopted more of this Fedora workstation, quote-unquote, distribution here, they have taken more of that approach, and that it's not just assembling all this software and shipping it to you without thinking about it, even if it sometimes feels that way, but really they are trying to make it a usable desktop. It doesn't quite get the same attention that some other platforms like Ubuntu does in that respect, which really is geared as this end consumer sort of OS, but it's definitely gotten further along that spectrum.
Yeah, I think it would be very unfair to the Fedora community and developers to characterize it as just slapped together without thought. I mean, there's literally no way for them to put the kind of polish on that you would see in an Ubuntu because they don't have an upstream. I mean, they're sitting right there at the mouth of the spring, so to speak. They are the very first stop. So for them to be able to produce the kind of polish you see in an Ubuntu that literally gets to start off with a fully complete distro, Debian, and just go from there and add polish, I mean, it's just not possible. Particularly not and maintain their own goals of having the absolute freshest, newest software available.
Yeah, that is a very good point. And the whole architecture is different. Most of the time we're talking about these Ubuntu LTS releases, and Fedora, they don't really have those. That's a whole other distribution in Red Hat and CentOS.
Yeah, I had a pretty long chat with Matthew Miller, project lead for Fedora, and that was one of the interesting things that he brought up was that they get asked very frequently. Users with the exact same concerns will ask for two, entirely opposite things. About half of them will ask to have long-term support releases, and another half will ask for a completely rolling release. And Matthew said that in his opinion, although they were asking for entirely opposite things, it was because they had the exact same goal in mind. They're afraid of updates and don't want to have to do them very frequently. So although it's entirely different, and then you have a long-term support release, you have something that you don't have to upgrade for a very long time, versus a rolling release where it's upgrading constantly. The user's idea and goal is the same either way, to say, don't present me with this scary thing that might break my system.
I just want it to keep on working. And to that point, I've been very impressed over the years, maybe not 10 years ago, but especially recently, upgrading Fedora boxes, which you do have to do a little more often than an Ubuntu LTS.
Every 6 months.
It works so well. And honestly, I absolutely adore DNF as a package manager. And there's just a plugin that does the upgrade for you. It has all kinds of very impressive sanity checks built in. And that's what makes it so robust.
This sounds like damning with faint praise, but I'm an extremely critical long-term sysadmin. So when I say that I just dove in with DNF on the terminal and had no complaints about it, that's a lot higher praise than it sounds like.
It's definitely not always as fast as some other package managers out there. Particularly Pacman comes to mind. But part of that is because it's doing a lot more. They place a huge emphasis on correctness and safety that you just don't always see in other systems. Some changes I saw in Fedora 32 that I liked a lot was better support for restarting services at the end of an RPM transaction. They've basically added some stuff to the package system here where you can declaratively tell the package manager what services need to get restarted and in what order, so you don't have complicated race conditions during an upgrade. And that's the level of polish that you're just never going to see on a system like Arch.
I still don't have a lot of experience with DNF to be able to speak very authoritatively about it, but one thing I did notice in my brief time was the DNF swap directive. I thought that was pretty cool. You can, on the command line with DNF, you can say, okay, in any package that says it has this for dependency, I want you to use that instead. And the ZFS on Linux folks use that so that you can do a sudo DNF swap ZFS fuse ZFS. And, now at one fell swoop, you've said any package that says it wants ZFS fuse for a dependency, satisfy that with the ZFS package instead. That was pretty cool. That's doing the same kind of thing in, Debian world with apt. It's still doable, but it's a lot weirder and dive into a config file kind of a process.
Yeah, definitely. Although this is probably a good time to talk more about your experience installing ZFS. I think a lot of things default to ZFS Fuse because, well, that's just the easy at-hand implementation, but you can get the real OpenZFS on Fedora if you put in a little bit of work.
Yeah, you can. It definitely feels like a second-class citizen. It used to surprise me a lot over the years. I would hear people say, ZFS on Linux is just clearly not where ZFS on FreeBSD is, and that shocked me because I've been using it since about 2010, and on Ubuntu, it has always felt like, if not first class, obviously, in 2010, you didn't have it just built into the kernel or the distribution. You did have to go install it from a PPA, and there was DKMS involved and all this, but, beyond that, you just add the repository and apt install ZFS utils Linux, and everything just works. You can immediately create a pool. You can restart. It will automatically load your pool, automatically load the modules. There's nothing goofy about it unless and until you encounter a DKMS build problem. And even those, of course, have gone away since Canonical took over and brought ZFS on Linux into their own repositories. There's not even any DKMS involved anymore. I kind of expected that going into Fedora, it would just be like, a trip back a few years to, when I needed to install a PPA on Ubuntu and do an install from there. And the process is a little similar, but it's a bit more complicated. You have to do that DNF swap in addition to the installation that I mentioned. And more importantly, the result that you're left with, it's a lot more half-finished. After installing ZFS, it didn't automatically load the kernel module. Attempting to load the module manually also failed.
Oh, no.
It appeared as though the headers weren't installed, although the headers were, in fact, installed. When I tried to do a forcible DKMS installation, it said that the headers weren't available, and I needed to point it to where they were. That frustrated the crap out of me, so then I did a DNF update and, got new everything, including the kernel and the kernel develop package and the kernel headers package.
Everything you need to actually build the DKMS package.
Exactly. And doing that broke dash to dock, and my launcher went away. And going into GNOME Tweak, which was more difficult than it should have been because the utilities window in applications wouldn't expose the entirety of the bottom row of icons. The text was cut off. So you better know what, the little picture looks like for tweaks to get back into it. Once you got into there, you got the warning icon over dash dock that just said it was broken, and that was that. So I gave up and did the old 3-finger salute and restarted the VM. Dash to dock did work again after the restart. It still would not load the ZFS kernel module, or it had not loaded the ZFS kernel module, but this time when I did a mod probe ZFS, it worked. It loaded. I created a pool out of sparse files, and I restarted the VM again, and when I restarted it, my pool was not imported, and the module, again, was not loaded.
Confusing.
I went and looked that up online and discovered that there are a couple of systemd timers that you should enable, so I enabled 3 of those ZFS-related timers and restarted again, and I still had no pool, and I still had no module.
Look at you using systemd timers. But yeah, that does sound pretty confusing. I mean, on the Ubuntu side of things, even in the old days, once you installed it and set things up, that was just going to be loaded. You'd see it already loaded by the time you hit your first terminal.
Yeah, you're just done. Everything just works. So anyway, after the several reboots, installing timers, and still not having the module load automatically, I dug a little bit further, and I discovered that basically there's a bug in the systemd timers that are installed, and if you don't have a pool on actual disks, block devices, not just files, then for whatever reason, the timer doesn't successfully load the kernel module. There may be a race condition involved in that. I don't know. I didn't dig too far, but what it boils down to is once you manually one time load the kernel module and then create a pool on actual disks, not just sparse files, then when you reboot, the systemd timers will function and it will load the modules and it will import your pools the way that it should.
I see. So you can get to a place that works as expected, just with a little more work.
Yeah, and the whole thing definitely does not inspire confidence. This is not the level of things working after you install it that you really want out of a file system that you're going to depend on. You're left with this feeling that you've built something on a foundation of sand. And of course, you are still left with potential DKMS problems, and eventually you will have an issue with DKMS that you're going to have to manually resolve.
Yes, and there's some danger. We're just talking about how great it is that on Fedora, you just get new kernels, right? You get the latest and greatest Linux kernel, but sometimes the OpenZFS project doesn't quite support whatever random breaking change happens in the exported modules in the Linux kernel. And that can cause problems for you, the DKMS user.
End of the day, if ZFS is important to you, and it may not be, I'm not saying everybody has to be the kind of, must-have ZFS person that I am.
And you might not need it on every system if you've already got it somewhere else on your network.
Yeah, you might not. But if ZFS is important to you, Fedora is not a great platform for that at the moment.
Which we should say isn't necessarily Fedora's fault. There's a lot of other issues here, and part of that is just the current setup of the packaging, and of course the kernel community's view on the licensing issue, regardless of if we agree with that.
Absolutely. This is in no way Fedora's fault. You could, if you wanted to, complain that the OpenZFS project itself should maybe support Fedora more thoroughly, or you might take the position that they can't support absolutely everything, fully to the nines, and because Fedora positions itself so far on the edge, unless and until Fedora does decide that, their own community wants to take on maintaining, ZFS in their repositories, then this is just kind of continue to be an issue. It's not Fedora's fault. It's just a real world constraint that at least for now, the way things are, if ZFS is of primary importance to you, you probably shouldn't plan on Fedora, unless, again, just you're willing to deal with all this. And maybe if you're the kind of person who's really attracted to Fedora, maybe that will just be okay for you. You're like, I like tinkering with stuff. I don't mind fixing it when it breaks, in which case, go nuts.
Yeah, that's certainly true. Fedora does feel a little bit more like a tinkerer's, developer's workstation. I do enjoy that at times too, because right out of the box, like, Git's installed. There's a whole bunch of dependencies that you just already have on a system because they expect that you're the type of user that's going to be using all of those tools. That's not true, probably, for the majority of desktop users out there. But in my circle, hey, I like it. All right, well, you hinted at this a little bit already, Jim. This was really your first go at a Wayland desktop. What did you think?
Honestly, Wes, it was kind of a big nothing burger. Wayland was the whole reason that I made a definite point to install on bare metal first, and I spent probably an hour or two playing around on the bare metal, and I was really hoping to see some kind of like, oh yeah, I can tell this is just next generation, things are snappier, windows drag more cleanly, videos play more cleanly, something like that, and honestly, I didn't see it. I mean, everything was fine. I spent probably an hour watching, videos on YouTube in 1080p in Firefox, and there wasn't any tearing and there wasn't any flickering, but there hadn't been on the same laptop under Ubuntu 19.10 either. So it wasn't broken, but I didn't see anything great out of it either. It was just, okay, that's Wayland instead of X11, and that's kind of at a lower level than I really care about because it's not exposing any differences that I can see that I care about.
Honestly, that's been my impression of Wayland too. For the most part, I haven't noticed. Occasionally, especially on lower-end systems, I have felt with Firefox's support of Wayland rendering that on long pages that are eating up tons of RAM and I'm scrolling for ages, Tumblr, I'm looking at you, it did feel snappier. And on those lower-end laptops, a few releases ago, not 1910, but before that, I'd experienced some tearing and some problems. But you're right. We've come a long way on Linux desktop, Wayland or not. So I think, honestly, the biggest accomplishment of Wayland these days, besides, there are some architectural things, some security considerations that are worth talking about. But the biggest win is just you can make it work as a desktop and never notice that you're not on X.
Yeah, I wondered about that on the lower end systems as well, because I'm pretty fortunate these days to be able to almost entirely be using pretty nice machines. I mean, even when I'm using just kind of reclaimed salvage hardware that, got cast off from somewhere, we're usually talking about an i7 with 8 gigs of RAM that's only, like 4 or 5 years old. It's still pretty nice in the overall grand scheme of things. So I wondered if that was coloring my perceptions. If, maybe if I were instead using an 8-year-old i3, maybe I would notice the difference in smoothness with Wayland.
Yeah, definitely. And unfortunately, I think there are still some features missing from Wayland. It's under active development, and we're still figuring out how to make the full expected desktop experience work there, especially if you're doing some niche activities like streaming or trying to share your desktop. Not all of that's figured out, but a lot of good work has been done, and I'm hoping for a Wayland future that works out pretty well.
Well, I think ultimately, Wes, we don't have a choice. We're headed for a Wayland future eventually. The question is when we get there entirely. I think the good news here was that for most people, it will pretty much work for everything that they want to do already, which Fedora has demonstrated. I think the other side of that coin is also good news in that, if you're not ready to go there, if you do have these niche needs and you do need to stay on Xorg for now, that's okay. You're not really giving up anything huge.
Yeah, really. It is the best of both worlds. And you've kind of underscored one of Fedora's purposes, to my mind, which is just that they are a testbed for these things with a nice fail-safe out. You can just, at the GNOME login screen, choose to run it on X11 if you'd like, and that still works great. Well, that's enough about Fedora. I'm glad you gave it a try, Jim. But you mentioned your experience with ZFS, and that makes me want to talk more about our favorite file system. Now, 2 episodes ago, in episode 428, we talked about your experiments in benchmarking RAID performance in a variety of configurations. That was fascinating, and I'm so glad you spent the time doing that. But in the back of my mind the whole time, I wanted to know, how did this work with ZFS? Thankfully, you've now done that research as well, and the results, well, They're fascinating.
Well, Wes, as the British school teacher says in The Wall, how can you have any pudding if you won't eat your meat? Honestly, doing the RAID analysis, the conventional RAID analysis for me, that was eating the meal so you can get to the dessert that you're really hankering for, which was the ZFS testing. This is what I had in mind all along, but I felt like if you don't actually test and fully understand RAID, then you can't really understand what ZFS brings to the table and where it's better. And also, honestly, where maybe it's not quite as good.
Yes. And I think in the real world, especially for experienced sysadmins who are coming from big hardware RAID systems, they're going to want to see those comparison numbers if they're ever going to make the jump over to ZFS.
You hear people say that they tried ZFS and it didn't work for them for one reason or another. And as someone who ZFS has worked incredibly well for, it can be a little strange hearing that and confusing. And this was an opportunity to, maybe see where that comes from. There's a big temptation to just say, oh, well, you must be doing it wrong because this has worked really well for me. But it's a lot more helpful to say, well, I've really thoroughly tested all the things and I know where one thing works well and another thing works better.
Okay, well, to start things off, over in the RAID discussion, a lot of your work there was all about how performance scaled in different configurations and with a different number of disks. And you've shared some complaints with me about folks' opinions on ZFS scaling as it relates to VDEVs, or, as they might think, spindles. You wanted to disprove that, right?
Yeah, absolutely. That's one of the things that I get frustrated with really frequently, trying to help people with their questions. In the ZFS world, you see all these folks that go out and get a 24-bay server and they throw, 22 or maybe all 24 bays into one single wide RAID Z2, and then they're confused at why it doesn't perform well. The answer there, which is, pretty widely understood and well accepted among people who really know what they're doing with ZFS, is performance doesn't scale with spindles. Performance scales with VDEVs, particularly IOPS, but honestly, in general, even throughput tends to scale a lot better with VDEV count than with just, disk count in one gigantic VDEV. So that was something that I wanted to set out to, prove is maybe the wrong word, but very thoroughly demonstrate, let's say that.
Maybe now's a good time to review a little bit of the difference between what we're talking about when we say a VDEV and just a spindle.
Before we talk about VDEVs, we need to talk about the pool itself and the way it works. A lot of people have the misconception that a pool is just sort of what you call your system and then you have a VDEV in it. That's not true. A pool is a container of one or more storage VDEVs, and each one of those VDEVs may be as simple as a single disk, or it may be something more complicated, like a RAID Z1 array or a mirror VDEV. Above and beyond that, even the people who understand that a pool is a collection of potentially lots of VDEVs, they frequently have the idea that it's just sort of a funny-looking RAID 0 that stripes. That's not really correct either. The pool distributes reads and writes amongst all the VDEVs. It does it mostly in accordance with how much free space is available on each, so to fill them up at a rate that leaves the whole pool becoming full on all VDEVs at once. But in more modern ZFS, there's also some concession to which VDEVs are more currently very heavily utilized. So if you've got a really heavy read workload on one VDEV, it might get bypassed for more idle ones when it's time to commit some writes.
Yet another example of ZFS knowing a lot about your underlying hardware and trying to take advantage of it.
Absolutely, but the really important thing to take away from here is that the pool is complex and the method by which it distributes reads and writes is not guaranteed. That can change.
And that's at the pool level.
Yes, that's at the pool level. Now, the other thing is there is no redundancy at the pool level. ZFS is very famous, and rightfully so, for working harder than any other file system to keep your data safe and intact and with maximum integrity. But all of that happens inside the individual VDEVs. If you create a pool of single disk VDEVs, you have no redundancy, no parity. It will die the first time one of those drives dies. So don't do that.
Right. I mean, that's kind of like the striped RAID 0 sense. I mean, different because it's ZFS, but the same sort of redundancy.
Or lack thereof.
Right.
I like to say the pool is not a funny-looking RAID 0. It's a funny-looking JBOD when it comes down to it. Just a bunch of disks. But anyway, let's move on beyond that. Now that we understand the pool can and probably should contain multiple VDEVs, not just one, we can talk about the different VDEV types. And those are mirror, and actually a single disk is really just a special case of a mirror VDEV. It's a mirror VDEV with only one node. More frequently, you see 2 wide mirrors, but you can make them any width. You can have one single mirror VDEV with 8 disks in it if you want to. So you've got mirrors, and then you've got RAIDz 1, 2, and 3. And a RAIDz 1 is similar to RAID 5 in that there's one block of parity for each full stripe. A RAIDz 2 has 2 blocks of parity. A RAIDz 3 has 3. For example, for a RAIDz 3, you can lose up to 3 disks out of that VDEV and not lose any data. But once you lose your last parity disk, the VDEV becomes what we call uncovered, which means you now have no way to recover from any further corruption, not just loss of a disk, but if you have a corrupt block, when you discover it, you're just stuck with it. You've got nothing to rebuild it from.
Right. You don't have that parity anymore. You've lost that. So there's no information to help restore the file.
The real answer here is, again, on performance. The way that your pool performs is much more closely followed by how many VDEVs you have than how many disks you have in any individual VDEV. Performance does scale up somewhat in many cases with a wide RAIDz VDEV, but not very reliably and not very far. Whereas your VDEV count, the scale is pretty much linear. The more you add, the better it performs. When I say that performance scales linearly with VDEVs, what I don't mean is that performance is the same whether you've got 4 RAIDz 2 VDEVs or 4 mirror VDEVs. What I mean is that the relationship of your performance from 1 VDEV to 4, if you started out with 1 mirror, then it scales the same way going from 2 mirrors to 3 mirrors to 4 mirrors. And the same thing happens if you start out with, say, a 6-wide RAIDz 2. Your performance goes up by the same increment with 2 of them, 3 of them, 4 of them. Whereas going from one 6-wide RAIDz 2 to one 24-wide RAIDz 2, you're not going to be happy.
And I guess that makes sense with what you introduced us to in the functioning of the Z pool itself, right? I mean, it's there to distribute these writes among the various VDEVs.
That approach scales a lot farther than just saying, oh, well, now there's this insanely wide stripe that you have to write all your data to. Because again, the pool does not stripe. It distributes. There's a difference.
All right. Well, now that we're through the basics of ZFS, I'm curious a bit about how things change when you add more disks. I know we mostly talk about mirrored configurations for a variety of reasons, but what does that actually look like in read and write performance as you go from 2 disks to 5 disks to 8 disks?
It definitely does scale better per disk than conventional RAID does. With RAID 6, mostly what happens is you increase stripe size is everything just completely goes into the toilet. There are very few workloads that conventional RAID 6 will work well with in a wide stripe, but writes in particular are absolutely not one of them, and the wider the stripe is, the worse it gets. ZFS can save itself from a lot of that, and it does scale better, but particularly with RAIDz, you start seeing things get worse and worse the wider the stripe gets.
Part of that reason must be just because, you have more disks that you've got to go fetch data from, right?
Well, yeah, so any striped array has the problem that you end up having to light up a lot of disks one way or another. And there's a difference in design between conventional stripe RAID and RAIDz that ends up meaning that RAIDz performs worse with RAIDz and conventional RAID performs worse with writes. And the reason for that is because of copy on write and the variable stripe write mechanism in RAIDz. And conventional RAID, every write has to go across an entire stripe of all disks in the array. So if you've got a 24-wide RAID 6, then you're going to have to write 24 data blocks and then 2 parity blocks every time, no matter what. Now, that also means you've got a read, modify, write cycle. If you make a small write to a RAID 6 array that's 24 disks wide, and it fits on only 1 or 2 of those disks, you might not necessarily have to write to the entire 24 if it's a first write for that stripe. But for the most part, what's going to end up happening is you're going to have to read some other only partially filled stripe to figure out what's in it. Then you're going to have to add your data to that partially empty stripe, recalculate the parity, and then write the entire thing back out again. So it's really, really punishing. On the other hand, with conventional RAID 6, you can have a wider chunk size. Now, a chunk in conventional RAID refers to how big the chunk of data is on each disk in the stripe. For example, when I do a default creation of an MD RAID 6 array on 1 terabyte disks, 8 wide, MD-RAID decides that it's going to use a 512 kibibyte chunk size. So for every one of those disks, you're writing a 512K chunk of data. That means that if you write a 1 meg file, you'll only light up 2 disks.
That makes sense.
Yeah, that absolutely stinks for writes, because it means if you write 3 1 meg files in a row, it's going to write to all 8 disks, then it's going to read 6 of those 8 disks in, it's going to modify the value of 2 of them, and it's going to write back out again to all of them, then it's going to do it all over again for the third 1 meg file. So you've got a whole lot of ugly churn and extra ops in there.
Ouch.
And this gets worse the wider the stripe gets. So everything just absolutely goes into the toilet for writes on a wide conventional RAID 6 stripe. So things are different over on the RAID Z2 side. If you have the same 24-disk wide RAID Z2, and please don't do that, it's still not a good idea. Let's say that you set record size equals 1 meg. Now what that actually means is you've set the underlying block size for ZFS file system. And on a RAID Z VDEV, when you write a block to that VDEV, the full block gets distributed amongst all the disks in the stripe.
Oh.
Yeah, if you've got a 24 wide, then that means you're going to have to divide that 1 megs by 22. And let's break out the handy dandy calculator here. And we get 1024 divided by 22. That's 46.5K, roughly. So since everything goes in 4K increments, that means you're going to need, let's see here, 48K chunks. So that's not a whole lot of data on each individual disk. The good news is that when you're doing a write, you will light up all of the disks. So if it's single process, either write or read, that's going to work out really well for you. But if you've got multiple processes going on, it's going to kind of suck because you're having to light up every single disk to write just 48K chunks of data. That's not great.
Right, so one process is writing some of its data, that lights up all the disks, and meanwhile these other processes, well, they're left waiting around.
Exactly. Now, one thing that is a little bit different here, if you've got a more reasonable VDEV width, let's say that you're only looking at an 8-wide RAID Z2. Maybe you've got, 3 of these things to fit in that same 24-bit case. But if you're only looking at 8-wide RAID Z2s, well, now instead of splitting up that 1 meg record size over 22 disks, you're only splitting it up over 6.
Yeah, that's a big improvement. And I imagine the performance, that's got to be better too.
Carry the 4, blah, blah, blah. You're looking at 172K chunk size. Now, I'm saying chunk size because I need to talk about this. As far as I'm aware, ZFS doesn't really have a good term like chunk for the amount of data out of the block written to each individual disk in the VDEV.
That's an important concept, so it's kind of difficult to talk about without the right diction.
Exactly. So we're just going to go ahead and say chunk here, just like we would if we were talking about conventional RAID. A block is written across the entire stripe, and a chunk is how much is written to each individual disk. And if you've got 8-wide RAID Z2 with 1 meg record size, then you're talking about 172K chunk on each disk. Obviously, that's going to perform better than only a 48K chunk.
Yeah, I'll say.
Now, Wes, the flip side of that is, again, this is why RAIDs work really well on conventional RAID, and they do not work as well on RAID Z2.
Interesting. This was a very surprising fact to me, not having ever benchmarked it myself.
Yeah, it was a big surprise to me as well. I had heard people make this complaint, but my experience with ZFS has always been that the reads feel extremely quick.
Right, fast enough.
Not just fast enough, they feel lightning fast because of the ARC. A lot more of the reads come from cache on ZFS than they do from other file systems because you've got a much better caching algorithm. So everything tends to feel really quick. But when you dive right down in there and you do benchmarking on the bare metal, bypassing the cache, there's no way around it. RAID Z is slow to read compared to conventional RAID. And the reason for that is the flip side of what we just talked about. So it was bad on RAID 6 that we had to do this read, modify, write, read, modify, write, read, modify, write. That was terrible. It thrashed the disks. It stunk. But if we now hit that array with a multi-process read, now to read a 1 meg file, we only have to light up 2 disks out of those 24. If you read the same 1 meg file off of the 24 disk RAID Z2, well, now you got to light up 22. So if you got 8 processes or 10 processes or 20 processes all asking for 1 meg files, obviously that's going to scale a whole lot better on that, RAID 6 array than it does on the RAID 2, where every single one of those processes has to light up every single disk every time. We did talk about ZFS performing better on writes and conventional RAID performing better on reads, but we didn't talk about by how much. Usually on the ZFS side, if you've properly tuned your record size to your workload, you're going to see, we're just going to go ahead and call it an improvement factor for lack of a better word.
Improvement factor, you say, Jim? Okay. How are you calculating this?
Okay, so let's say that you read at 1 megabyte per second on ZFS and you read at 4 megabytes per second on conventional RAID. I would say that you've got a 4-to-1 improvement there on the RAID side, right?
Yeah, okay.
Now let's say that you write at 1 meg per second to your conventional RAID array and you write at 20 megs per second on the ZFS side. That's a 20-to-1.
All right, that sounds good to me.
You usually see an improvement along the lines of, between 2 and 4 or 5 to 1 on a pure uncached read workload. There's nothing going on but reads, and, it's completely at saturation for the system. You'll end up with a number between 2 and 4 or 5 times higher on conventional RAID than you do on ZFS. But when you do the same thing with the writes, when you have a pure write workload, and it doesn't really matter much whether you're talking small block size or large block size or sync or async, the numbers will differ, but you're generally going to be looking at anywhere from 10-to-1 to 20-to-1 and sometimes higher for the improvement for ZFS there.
Wow.
If you're talking about a system that is heavily loaded and has a significantly mixed workload, it may not much matter if your reads go at a quarter the speed, because your storage, you got to remember, it's half duplex. You can't read and write at the same time. You can only do one thing at once. So if your writes are going 20 times faster and your reads are going 4 times slower, now it's going to depend on the balance, but you may very well find that you have lower latency and higher throughput on your read requests on this system with a mixed workload than you would otherwise.
That seems especially impressive to me because with that write workload, you're still getting all the amazing ZFS benefits of the copy on write architecture.
Just to throw some hard numbers out there, if we're talking about an 8-wide array, RAID Z2 versus RAID 6, and 1 meg asynchronous write, then we're looking at a difference between 227 megabytes per second to 950 megabytes per second.
I know which one I'd prefer.
Yeah, so now let's go down to the 4K write side, and it gets even bigger. For 4K writes, again, we're talking about an 8-wide RAID 6 versus 8-wide RAID Z2. You go from 9.3 megabytes per second to 112.3.
Wow.
And if you thought that was bad, let's talk about 4K sync writes. So with an 8-wide RAID Z6, those go at 0.3 megabytes per second. On RAID Z2 8-wide, 7.2.
Right, and this is a workload where you really do care. I mean, if it's synchronous, that you're not going to wait for the operating system or the file system to flush this out sometime. You need to know that data hit the disk.
Exactly, and the other thing about that is, if you have much of this kind of 4K sync workload, it does not take much of it at all to 100% saturate the drives. And remember, again, your storage is half duplex. You're not getting any reads back out of it if you're 100% utilizing your drives, trying to trickle data down to them at 0.3 megabytes per second.
At that point, everyone else is left waiting. Well, that's a lot of lofty mathematics there. At the end of the day, Jim, I am kind of curious. I mean, you and I are both people that love ZFS, but for some workloads, from what you've said, maybe traditional RAID or MD RAID in the Linux world is what you might want. Are there workloads that you would choose for yourself or your clients that would bypass all the other benefits of ZFS and just use RAID?
The answer to that is a qualified no. Even in the absolute worst case scenario where, the uncached reads on a stripe RAID array, which, let's be clear, I would not generally be using stripe RAID or RAID Z either. I'm a big fan of mirrors, which do not have the same performance issue.
Right.
I'll go ahead and say it up front. When you compare RAID 10 to a pool of mirrors, the pool of mirrors outperforms RAID 10 in every single metric but 4K uncached reads specifically, where it's about half as fast. But again, you've got write advantages that in some cases are, 10 or 20 to 1.
And you've still got the ARC.
Even if we're saying, okay, so our workload is going to be almost entirely 4K uncached reads. And so things are going to be half as fast if you go ZFS than they would be with conventional RAID. It would make me sad, but I'd still have to go with ZFS because, I'm still getting automatic data healing with, checksums on every single block. I'm still getting rapid replication. I'm still getting a wealth of performance tuning abilities. I mean, one of the things we haven't really talked about here is just how versatile CFS is for performance tuning. We talked about chunk size on conventional RAID and how, ideally you would want to tune your chunk size to your workload, right? You don't want to have a big chunk size if you're working with like a MySQL database that's got 16K page sizes, right? Having 512K on a chunk would be terrible for that.
Yeah, absolutely. I mean, are we writing big files, small files, or overwriting something in place like with a database?
And that is tunable. When you create your array with MD-RAID, you can absolutely set the chunk size manually if you want to. You'd better do that if you're going to have something like a database running on it, rather than a general purpose file server. And you do the same thing on ZFS by setting record size, or if it's a ZVol, by with vol block size. The difference is that on ZFS, you can do that dynamically per individual dataset or ZVol, which, you can create those as easily as you might create a folder. You can just say ZFS create mypool MySQL, ZFS set record size equals 16K mypool MySQL, and boom, you created a place that's perfectly optimized to store your MySQL binary. By contrast, maybe you've got a place where you want to store your Linux ISOs and legally downloaded movies. Those are all going to be large files, so you want a 1 meg record size. So you say ZFS create mypool/downloads, ZFS set record size equals 1 meg, mypool/downloads, and you're done. Now, on the other hand, let's say that we're working with 24 disks here. However, we had the topology ZFS versus MD-RAID.
Right.
If we did the same thing on an MD-RAID, now we can still tune our chunk size, but it's going to be for the entire array. And if you want to change it, you've got to tear the entire array down. You've got to back up all your data, destroy everything, recreate it from scratch, reformat it from scratch, which on ext4 with a large array may already eat hours of your time.
Oof.
And you can't have both at once unless you're literally trying to do something crazy like partition your disks and have a different partition for the one than the other. And that's going to end up being pretty weird and not work out very well either.
Right. Good luck administrating that.
But with ZFS, it's just that quick and that easy. You can just change your performance level per data set, tune it to exactly the workload you need. And yeah, I'm absolutely not prepared to give that or replication or, self-healing arrays or inline compression, or, I could probably keep listing things for a while here.
Yeah, it seems pretty rare, even in the enterprise case of, having a cluster of storage dedicated to one purpose, where that level of administration friendliness and configurability isn't worth a, small constant factor of performance on reads.
Yeah, and if we're talking enterprise, you're usually not going to be seeing conventional RAID in the enterprise either. Usually these days, the storage in an enterprise setting is going to be on a SAN, and that SAN, it's going to be doing things proprietary, but it's going to be exposing a lot of the same basic functionality that ZFS does. If you administer something running Waffle, it's not the same, but you get most of the same feature set if exposed in slightly different ways. Well, Wes, I got to tell you, I really hate having to do it, but it's probably time for us to talk about this being our last TechSNAP.
Yeah, that's for sure. We can only spend so much time convincing everyone to use ZFS. And honestly, that makes me think that's maybe the point of the whole show. Being involved with TechSNAP has honestly been one of the best things in my life, and part of that is the amazing history of the show. TechSNAP Episode 1 happened way back in April 2011, all about Dropbox flaws, and of course in those days it was Chris and Helen Jude. They did an amazing 300 episodes together before Dan and I took things over. The Dan and Wes era didn't last as long as we might have hoped, but throughout all of this, ZFS, BSD, Linux, system administration, networking, And just being sensible about how you run computers, well, that's always been a theme. After Dan left the show, there was a brief little intermission with Chris and I. Tried to modernize things, cover a little bit more cloud topics, and maybe shift things from BSD over to Linux, which I think just set the stage for the Jim era. There was a time in between where we had Jim on, and he really proved himself, from talking about the next generation of HTTP or covering why WireGuard was so great even like 2 years ago. And that meant Jim was clearly a candidate for a host. And really, Jim, I can think of no one better to help steward the TechSNAP program than you because, you're a longtime system administrator, you have real-world concerns, you have a BSD background, and you love ZFS.
You're going to make me blush here, Wes.
And that's why I think it's so painful for both of us to make this our last episode. It's a painful time in the history of the show, but it's not necessarily done. We're just putting things on the shelf for now.
And that doesn't mean that you can't find Wes or myself on other podcasts in the meantime. Former TechSNAP host Alan Jude and I and Joe Ressington of Late Night Linux fame have a new podcast called 2.5 Admins. Obviously, Alan and I are at least 2 of those admins, and Joe's whatever fraction is left. You can find us at 2.5admins.com.
And I'll be continuing as a co-host on Linux Unplugged, and that's just linuxunplugged.com, where you can find Chris and myself opining about whatever's happening in Linux and open source community every week on Tuesday. As a final note, the whole back catalog will continue to be available over at techsnap.systems, as will the contact page if you've got any feedback for Jim or myself, or any favorite moments from the TechSNAP history. And really, at this point, I just have to thank you, the audience. You're the whole reason we do this, and that's why being a part of TechSNAP has meant so much to me. So, really, thank you for listening.
And as always, you can find me on Twitter at JRSSNet.
And I'm at Wes Payne.
Goodbye, everybody.